All right, welcome back to day 3. We are now on module number 3, and we're going to do our deep dive into tuples. And we'll see why we have tuples and list. We have two different data structures that are very similar. So what is the difference between a tuple and a list? Tuples start with parentheses. We saw the square brackets is how we start with list. But other than that, the construction of a tuple looks very similar, right? Just like a list. So I could say my tuple is equal to, we'll do the assignment operator here, and we'll do something in parentheses. And I'll say 1, 2, 3, 4, 5, 6, 7, 8, 9, and even 10. Why not? Now if I print the tuple, you'll see that it's got the parentheses here as well. So that indicates that it is a tuple. We can also check the type on it. You can always run type and surround that and put it in a print statement. And it'll tell us the type is tuple. So we've got tuples. What is the big difference between a tuple and a list? Well, the big difference is that tuples are immutable, meaning that we can't change it once it's been created. We can't add things to it. We can't remove things. In fact, if we do, we're going to end up getting an error. So let's take our list, or I'm sorry, not our list, our tuple, bring it down here and run it in this code. And what I want to do is I want to show you that we can access into tuples just like we could with list. So if I want to print, I can take my tuple and I can access into the tuple using square brackets. Let's say the 7th item. Tuples, just like everything in Python, are zero based. So this is the 0 item, 1 item, 2 item, 3, 4, 5, 6, and the 7th item. So when I print, you'll notice that I get the value of 8, not 7, because our tuple is 0 based. With list, there was multiple ways I could update things. I could take, if I made this into a list, let's create a list here. Now I'm going to do the same, make the list just like our tuple, except for convert it to a list. And with list, I could do things like, let's append something to my list. I could say my list dot append, and I could print, I could append the value 11 to it. And if I print out my list now, you'll see that the 11 has been added. If I try to switch and make the print out my tuple instead, it'll give us an attribute error. There's no such thing as append in tuples. So I can't append. Can I update items? Let's go back to our list example. And I can index into a list. We'll use our square brackets. And I'm going to update the 0th item. And I'm going to instead of the value 1, I want to make that equal to the value of -1. And then I'm going to go ahead and print my list. Let me comment out my tuple just so we can be consistent here. I got my list, updating item 0 in our list to be the value of -1, and then I'm going to go ahead and print it out. And there you go. So it did update our value to -1. Let's transition that over to our tuple. So comment this one out. And now I'm trying to update our tuple 0th item, which is 1 in this case. I'm going to try to convert it to a -1. And you'll notice that it says if I try to modify it, I'm going to get a type error. There we go. And that's a type error. Now, all you need to know for now is that there's different types of errors, and type error happens to be one of them. When we had it as our append, you saw it was an attribute error. I'll go ahead and show you that. So it's a different error. It's called an attribute error because there's no such thing as the append method for tuples. And we can check that also. If I put the dot and then I push my tab key, it shows you all of the different functions that I can use with tuple. And you can see I can only use the count and the index functions. If I do that same thing with my list, I'll delete this one and put my list in here, and I'll hit the tab button. Look how many more functions we have with list. I can clear it, I can append it, I can get the index, I can insert, I can pop, which means take one off the top. I can remove and I can reverse. So lists have a lot more functionality than tuples. So why would I ever use a tuple instead of a list? We'll go ahead and get that error out of our way. Well, I missed that section. Let's talk about why I would want to use tuples. All the way down here at the bottom. Tuples are, where is that? Integrity, right? So integrity is a big issue in cybersecurity and in software and all that. We want to make sure things are the way we intended them to be. They haven't been modified or changed. Immutability is one of those ways we can maintain integrity. So tuples, when I want to make something read-only, is a great way to make sure that that data has data integrity in it. So I can't try to modify my code by accident. I can't have, if I'm having co-developers, multiple developers on a project, and I pass them a data structure, and if I pass it as a tuple, then I know they're not modifying my data. I can make sure that it has integrity. So that's a real reason why we want to use tuples. Back up here to accessing elements, we saw how we can access them just like we can with the list. The big difference is we can't update them this way. I can access them this way, no problem. I just can't update them like we could with our list. So we'll grab this example. Let's put this back how it was. Well, that's going to give us our error, so we'll just leave it at that. Let's grab this code, bring it down here, and let's talk about accessing elements now. We said they're zero-based, and we said that this square bracket has nothing to do with list. This square bracket up here is defining it as a list because that's in the assignment side of the house, right? So this is saying, hey, I'm creating a new object and I'm assigning it to my list. What kind of object am I creating? Well, I see that it's square brackets, therefore it's going to be a list. Once I've already got the object created, such as my tuple here, now I'm free to use the same character to represent something totally different. So I'm using the square brackets here to reference inside my data structure. So in my tuple, and just like we could with our list, we can go backwards through it. So I can say -1, it's going to go to the end. And I could go 0, that gives me the beginning. And I can go anywhere in between. I can go from 0 up to 9, or yeah, 9, or I can go -1 all the way up to 10. So those are the values I can be able to access into my element. I can do some cool stuff with tuples, and I don't want to give this example. Let's do a different example here. We'll clear our cells here. So tuples support operations including concatenation, repetition, and length calculation. So let's use our tuple. Let's go back and grab what our tuple was. We saw this in we talked about list. I can do the length of it. I type len, parentheses, give it the variable that's holding our tuple. And let's go ahead and print that out just so you can see how that works. And that gives us, there's 10 elements inside of my tuple. I get the length of it that way. I can also use the plus operator. If I had, we'll call it tuple 1, and we'll say, let's create a tuple 2. And instead of numbers, because these are just examples, we could do letters. Anything that's a comma-separated list is fine, or comma-separated items. I can add them together. So let's go down here and talk about adding tuples together. So combined equals tuple 1 plus tuple 2. And let's go ahead and print our combined tuple. What happens here, oops, that didn't, tuple 1 plus tuple 2, there we go, I can't spell. I got an L, that's what happened, I got an extra. There we go. Now I can spell. Now it makes more sense, right? I got 0 through 9, A, G, and R. For those of you that are wondering what happened there, I actually had two variables spelled correctly already in memory with Python because I had done some examples earlier. In fact, I had done a very similar example earlier with just different data in my tuples. So that's why I was able to add those variables, because stored in Python was references to those variable names. But when I have them spelled correctly, I can overwrite them to our new values that we were trying to see here. The way it works is tuple 1 is going to be laid in there first, and then right after that we're going to add to the end of it our tuple 2. And you can see I put them in with double quotes, but it has them in here with single quotes. Either way, they're still strings, it's just the way that Python decided to store them that way. Okay, so that's using the concatenate operator. And concatenate literally means to just combine. And so it basically slams them together, right? One after the other. I could combine tuple 1 again. So it goes tuple 1, tuple 2, tuple 3, or tuple 1, tuple 2, tuple 1. It's going to go 1 through 10, AGR 1 through 10. So I can actually combine. Now this combined tuple is a tuple of its own right, so I cannot append to it. That's going to give me my attribute error. I cannot try to modify a value. And we'll say 4, we'll say that equals W. Why not? That's also going to cause a type error. And I'm foreshadowing what we're going to cover in a few days, right? So right now we're on day 3. Day 5, we'll talk about error handling and how we have to deal with different types of errors. So these are two different types of errors: attribute errors and type errors. And there's a whole bunch more. Okay, so let's get rid of the error in our code. And let's talk about how we can do repetition with tuples as well. Say I want to have a tuple, we'll call it tuple 3, and let's make it, I don't know, we'll put in there just one value of 1, and I'm going to multiply it by 10. And let's go ahead and print tuple 3. What's going to happen now is it's going to create a tuple with the value of 1, and it's going to replicate that 10 times, and then combine that into tuple 3, which is now going to be a tuple in its own right that holds 10 items in it. Oops, I got my type error word. What did I do wrong here? Oh, it's not iterable. Oh, yeah, I need to put it in. Sorry. Let's see if that works. Ah, okay, there we go. And I bet I can actually now get rid of our... So this is a nuanced thing. I was trying to make a single element tuple, and it gets confused because if it doesn't know the parentheses are doing mathematical calculation parentheses, or if it's for a tuple. So if I put a comma, therefore it says, oh, okay, I know you're not doing math now, you're doing it for a tuple. So when I did this comma, that allowed me to do the multiplication. So tuple 3 is right here. Let me comment out these other ones so they're not cluttering our output. We'll go ahead and comment these out. And we'll rerun our code. Actually, what we'll do is we'll just write our own section of code and just copy this. That way I can leave this example for you all later when you're using this notebook. You don't have to uncomment the code. All right, so there we go. We can also create tuples by replicating them. So if I have something like 1, 2, 3 and I multiply it by 10, I'm actually going to get 30 elements. It's going to go 1, 2, 3, 1, 2, 3, 1, 2, 3, and it's going to do that 10 times. So I'm going to get 30 total elements. In fact, if I do the length of that, you should see that you actually get 30 items. And there we go. So we get 30 items when I do the replication. That's the wrong one. When I do the replication of tuple 3. Another really cool thing about tuples is it's the default return type when we talk about functions. So another foreshadowing, day 4, we're going to talk about functions. I'm going to give you a quick example of what a function looks like. Again, right now, I just want you to see the return type, but I'm going to have to show you how to define a function. In fact, we use the DEF word. See how it turns dark green and bold? That means it's a reserved keyword. So DEF stands for define, and we'll just call it my function. And I'm going to take no values in, so I'm just going to do open close parentheses. Then I'm going to do my colon. And we know whenever we do a colon at the end of a line, we're going to create a code block after that, right? So it's going to be indented 4 spaces. And everything that's indented 4 spaces is part of my function. So first thing I want to do is print something like in my function. Then the next thing I'm going to do is I'm going to return. I'm just going to return a couple values. I don't know, I'll just say 1, 2, 3. Now, usually in a function, you're going to do some math or something that's important, and then you return back the result to whoever was calling your function to begin with. I'm just going to return back three random values. The important part is how they get returned. So let's define our function. So now you see that I ran the code, it gave me a number. That means that this function is now in memory in Python, and I can actually reference it and create a instantiation of it is the term, right? So I'm instantiating the function and running it. I run it by calling its name, my function, and I give it the parentheses. Now we're going to put it back to a variable, so we'll just call it myvar. So I got the variable name that I wanted to create. I've got my assignment operator, and then I'm calling my function by its name, and I'm calling it as a function, so I have open and close parentheses. And if I wanted to pass things into it, I would actually put the things I want to pass into it between the 2 parentheses. This is how I encapsulate what I want to pass into my function. My function doesn't take anything, so right now it's empty. When we get to functions, you'll see how that changes, but just understand the syntax a little bit there. And then returning is what gets passed from my function back to what I'm assigning to my variable. And we'll go ahead and print myvar. We'll go ahead and run that. And you'll see I printed out in my function, because that's the statement that gets printed here. And then I'm printing out the value of my var, and you'll see that it's got parentheses. This indicates that the variable myvar data type is, in fact, a tuple. We can also verify that by calling the type method or the type function on it and running that as well. In fact, it does tell you that it is a tuple. There we go. Now we have both. I have the actual value, and then I also tell you the type. So what exactly is tuple unpacking? Tuple unpacking is the ability for us to take something and split it into multiple variables. So for instance, let's say I have coordinates, and we'll say I have XYZ coordinates. So I have, I don't know, some math coordinates. We'll say 12 units in the X direction, 34 units in the Y direction, and 4 units in the Z direction. And let's make this into a tuple, because we're going to do tuple unpacking. And again, let's just show you what type it is. So print, open close parentheses, type, open close parentheses, and paste our variable name in there. And you'll see that it is in fact a tuple. What tuple unpacking lets us do is do a comma separated z equals our tuple value. Because we have three values in our tuple, 12, 34, and 4, it will dynamically assign x to be the 12, y to be the 34, and z to be the value of 4. And let's go ahead and show you that in action. We'll comment this one out, and we're just going to print x first. Go ahead and run that. And you'll see I do, in fact, get the value of x is 12. Y is 34, and z is 4. So it correctly unpacks it. What if I added, I don't know, we'll say a. So now I have more variables on the left-hand side than I do on my right-hand side. As you guessed it, we're going to get a different type of error. This type we get a value error. And it tells us explicitly not enough values that we're able to unpack. So it's expecting 4 values to get unpacked, but we only have 3 to give you. So we can't do it that way. What if I did it the other way? I say, hey, I only want x and y out of my tuple. I also get a value. We say too many values to unpack. Well, I could also do what's called an underscore. And so underscores a variable that kind of just syncs and calculates, and it's like we're not going to use it. It's like a dummy variable that we're just throwing it away. But we still have to have the right number. So we go y, comma, underscore. If I don't care about a variable, I normally store it in my underscore. And so there we go. Now it is a valid variable, right? So if I did underscore here, it is the value of x or of z. But this is just the nomenclature of things I don't care about. In fact, if I didn't care about x or y, I could do 2 underscores, and all I get out is x. That's the only thing I care about, right? Okay, so that's tuple unpacking. There's not as much to take in with tuples because we just learned a whole bunch of stuff with list, and a lot of them are overlapping with tuples. How do we index into them? How do we slice them? It's the same way to slice tuples as it is to slice list. So we don't really need to rehash that material, but there are some cool things that we can do with tuples that we don't typically do with list. And I also mentioned that we use tuples for data integrity. If it's immutable, means that it cannot be changed by code, right? And that it helps us make sure that we don't mess with our data. Now for this section, I have one challenge for us. The challenge is to write a program that finds common elements between 2 given tuples, right here, tuple 1 and tuple 2, and I'm looking for common elements. So things that are the same in both. And then I want to store that into a new tuple. We'll call it tuple 3. And then we're going to print the tuple 3. Now I will show you how to do this the intuitive way, and then I'll show you how to do it also using comprehensions. So we can do tuple comprehensions just like we did list comprehensions. But we'll start with doing it in an intuitive way. I can use our for loop, and I can say item in tuple 1, tuple 1, colon. Actually, I should say, we should say T1 for tuple 1. Then I can do what's called a nested loop for T2 in tuple 2. And I can say if T1 double equals, I'm doing comparison now, T2, if that's the case, I have an item that they share in common, right? So my outside list is going to go 1, then 2, then 6, then 8, then 3, 5, and 8. My inside list is going to go over all these items, and I'm going to compare one by one, and if it's equal, I'm going to store that value. but I'm going to store it in a list because I have to have something that's modifiable. We're going to call this list1, and it's going to start out with an empty list. As soon as I get an item that they share in common, I'm going to append it. And since they're the same, I can store either T1 or T2, it doesn't matter. And then I can break. And that'll just break out of the T2 list and go back to the T1 list. When this is all done, I can say tuple 3 is equal to the tuple constructor, and I'm going to put list1 into my tuple constructor. And that's going to convert my list into that immutable tuple and store it in variable tuple 3. Then we'll go ahead and print tuple 3. And there we go. So I have items 6, 8, and 8 are duplicates. So my items 6, 8, and 8 are duplicates. Now this 8 was in here and it found it here. This 8 here found the same 8. So it's kind of what I wanted to do, and I just wanted to show that it does, tuples do allow duplicates. Lists also allow duplicates, but that's what we intended to have happen. There are other data structures, such as the set data structure, which we haven't gone over yet, but that does not allow duplicates. So if I wanted to get rid of duplicates, I could convert to a set and then get it back to a tuple. So I could technically can say convert to a set and then convert to a tuple. And when I run this, you'll see that I get them without duplicates. And if I wanted to sort this whole thing, I could sort my list first. And so now I'm going to get 6. Oops, I got a type error. What did I do wrong here? List1 sort. That's what I'm trying to do. I gotta one second. I gotta convert my list. I gotta sort it first, then convert it to a set, then convert it to a tuple. There we go. Oops, wait. Sort should have. What am I doing wrong? Oh, I bet it's the set that needs to be sorted. Ah, okay. So I need to do this outside of my creating my tuple. Let's create a new variable. We'll call this S1 or set1. And I'm going to create it from our list1. Now I'm going to convert set1 into our tuple. But first, I'm going to sort. Just make sure that it has a sort. Does it have a sort ability? No, that does not. Okay, so sets cannot be sorted. That's probably our issue. And it's going to choose the order that it wants, so it's going to make it 8, 6. No big deal. Oops, what did I do wrong? Oh, list1. There we go. So back to how I intended it to be. All right, how can I do this now with list comprehensions? Well, with set comprehensions, I could say, well, let's copy the 2 items here, and we're going to create them, well, we'll just leave them as tuples. With set comprehensions, I would say expression for variable name, our name, in, then I'm going to give it our iterable item, which is going to be tuple in this case. And then I can do an if clause, which I haven't taught you yet. There's an if. Now I can do some kind of condition, right? I can say if my variable name is in my other tuple. So my expression is just going to be variable name. And we can, instead of calling it var name, which is not that intuitive, we can say item. So my list here is going to be filled with items if my item is found in tuple 2. I'm iterating over the entire list or tuple 1, item by item, and I'm checking each item to see if it's contained in tuple 2. If it is, I'm putting it in this new item that I have that's a list. So if I just do my list is equal to this, I should be able to print out my list. There we go. So we got the same results in 2 lines of code that I did in 5 lines of code, actually 6, 7 lines of code, because I forgot about these 2. So 7 lines of code I did in 2 lines of code. But I created it as a list. I want to really create this as a tuple. Tuple comprehensions are identical to list comprehensions. So I could just switch the square brackets for parentheses and call it a tuple instead. It's a generator expression. So I need to convert it calling the constructor for tuple. And there we go. So now I did it in 2 lines of code. If I want to get super fancy, I could do it in 1 line of code and just print the entire tuple. So I'm going to encapsulate the entire statement in our print statement. There we go. That's called code refactoring. I started with this gigantic set of code, and I've refactored it now into 3 lines of code. And it's a little bit more obfuscated, right? This I can kind of walk myself through, see what I'm trying to do here. I'd even put comments in here. Having it all kind of put on 1 line, I would definitely want to put a comment here saying something about finding similar or what is the term they used? Common elements. Between 2 tuples. Right, so that's, I would make sure I have a comment so I know what's going on. All right, and then my textbook solution, very similar. I just did that exact same tuple expression up here. I called it item. You know, what I call it here? Yeah, I called it item as well here. But just remember how the list expressions work, or list comprehensions work, and tuple comprehensions work the exact same way. You just do parentheses versus having the square brackets. That's the biggest difference, right? Besides that, we have the expression that we're going to put into our tuple. We have the variable name that we've come up with. We have the item that we're going to iterate over. And then we have this if condition. And this if condition is true, then it runs our expression. If the if condition is false, it does not run our expression, item by item through our tuple. All right, that's what I've got for tuples. Our next class will be the final one in day 3. So you got 1 more class to go. And we're going to focus and do a deep dive on dictionaries. So take a quick break, and I'll see you in a few minutes.